welcome everyone to our next session. So to not waste any more time, I'll let Cedric and Milan take it over. Give a warm welcome.
Yes. Hello, everyone. For our session on the package torchTextClassifiers. I'm Cedric, and I will be presenting with Meilame. We are both data scientists from the innovation team at Insee, the French National Institute of Statistics. And before we start, Meilame just posted the link to the slide if you want to follow with us. A bit about us. We will talk about our MLOps pipeline for text classification at Insee with a specific use case and explain the constraints that push us to open source Python package toolkit. Our main use case is automatic. Our main use case is automatic nice coding. In French, we say code APE for the National Business Registry, Siren for us. The goal is given an activity description and some additional information on a business. We have to assign one of more than 700 nice labels. So the task is a sparse label extreme multi-class text classification with additional variables. And we are dealing with hundreds of possible classes. An important point, if the model is unconfident about a prediction, we need to pass it to human annotators. So we need to be We also face some specific constraints in our environment. We have a lot of training data, but it's not always reliable because it came from previous classification made either by a deterministic algorithm or more recently by a fastText model. NAS is a nomenclature for activity classification. Statistical in European, I think, statistical nomenclature for activity. It's coded on 5 positions. Another constraint we have, we can train our models on GPUs, but we need to perform non-batched online inference on CPUs only in a secured offline environment. And we need to be responsive on with our inference time. We have a need to be under 200 milliseconds per prediction. So with this constraint in mind, I'll let Meilame explain how we at Insee we modernized our pipeline.
So hi everyone. So I'll jump into the MLOps pipeline now. So you understood that this is a highly critical machine learning pipeline that we have here at Insee because we have almost 10K businesses that are declared every day. So we need a very responsive machine learning pipeline to assign the right code to each business. And so to do that, we have tried to get going with the ideal MLOps pipeline where you come from data, you train your model, then you develop your deployment. Then you have your operations that are continuous, and you have to monitor your model and then look back to monitor your model and to look for data drift or model drifting and so on. So this is the MLOps pipeline. It's eternal knot in a sense. It's a loop that is going on permanently. So this is the ideal MLOps pipeline, the theoretical one, and this is ours. we try to get going on that and to approach the ideal one from data store. So we are using a lot of cloud-based softwares to achieve this ideal pipeline. From Minio for data storage, we do some data cleaning and versioning using DVC, and MLflow is highly critical in our pipeline. Then we serve the model through an API, which is containerized and sent to the production teams that are in other city. They are in Nantes, which is a city in France. But we deploy on our end also. And then there's this monitoring dashboard using always open source cloud-based softwares. So you can see that some of here the transmission between the production teams and the innovation lab is not automated, and this is something that we want to really improve. So as we said, there's a next. Sorry, and just to show you a bit, the package torchTextClassifiers will be involved in here, the model development case, and we will deep dive into that later on. So MLflow is highly critical here. We use it as a training monitor. We use it as a model store and a versioner, in a sense, to keep track of the different versions of the model put in production. And we use also the PyFunk object from MLflow, which serve as a model wrapper. So what is a wrapper? It's that you package everything, all the metadata necessary, the pre-processing steps, and so on to run inference. So this is the code for MLflow wrapper. In a sense, you go from the raw text to the labels at the end. So this is how we use the full capabilities of MLflow to do our MLOps pipeline. And this notion of wrapper, to wrap your machine learning model into something that is a bit above, that gets from raw text and not tensors or some really raw text to pure labels. This notion of wrapper will be central in the way that we have designed the torchTextClassifier package. Then we are serving the model through an API, which is quite classical. And this serving of an API is very easy thanks to the idea of a wrapper, because you just have one, in a sense, route, which is the predict route. And this predict route calls the predict function from the MLflow wrapper. So it's very easy to deploy once you have packaged everything in a nice way. So that was just to show you a bit how it's done, in a sense, what's the context of the pipeline and so on, and we'll get going with the package just after that. And the API streaming is quite nice. You can completely play with it anytime if you want to. So yeah, you can see that I can describe an activity, and then so it's in French. Sorry, but boulangerie, of course, and then you are assigned a code. So that's what's the context and the use case that we have here. And so now let's deep dive in the core of this presentation, which is a text classification toolkit, in a sense, a unified framework in PyTorch for text classification. So as we discussed, within this whole MLOps pipeline, until 2021, in a sense, from 2021 until last year, we had a fastText. fastText was a library developed by Meta, based on a methodological paper that they published in 2016, I guess. And so they had a Python library that was used by many people out there, which was very nice because it was quite powerful, quite in terms of accuracy performance, and also very efficient in terms of inference time. The problem is the library repo has been archived last year on 2024. So it means that Meta will not maintain this library anymore. And this non-maintenance is highly problematic in the medium term, especially if, like us, you have a highly critical production MLOps pipeline that is based on this model. First, of course, you can have non-fixable bugs, you can have conflicting versions of dependencies, and also you cannot modernize your model, especially in a time where NLP is like on the surge and really growing out there. So 3 points that were highly problematic in our pipeline. And this pipeline is, as I said, very critical for the organization, because if your model is not reliable, you will have to hire a lot of human workforce to annotate the data. So we want to avoid we really want to avoid a crash of the machine learning model. And so internally, we decided to move to PyTorch. So why? Because we want to adapt and customize our own architecture for our own specific needs. So we indeed have some text classification, but we also have some categorical variables on top of this text, and this was not handled by fastText, for instance, or at least not natively. So we want really to natively handle this very specific use case, which is text classification with categorical variables. Then we want to limit the dependencies to external libraries to internalize the maintenance and access to the vibrant deep learning NLP community. For instance, you have a lot of libraries that are built on top of PyTorch, such as Captum or so on. And also you connect Hugging Face ecosystem thanks to PyTorch. Like everything is done in PyTorch right now in the deep learning universe. So we really wanted to catch the train and to keep up with this modernization of the different pipelines. Then we decided to package the architecture. This is quite, I think, or let's say unique in a sense, because it's not common to package to do a Python package based on a PyTorch architecture. Usually, you do your training, you code your architecture, and then you just train, and that's it. We decided to push the model architecture into PyPy. So why? Because conceptually, the model architecture has its own life. It can be used not only for nice coding, but for any text classification use cases. And it's like quite common in the statistical, official statistics universe, also in the government administration universe. You have a lot of text that you want to classify. It's something that is quite common as a task. And so the model architecture can be used for other use cases. It has its own development, versioning, and so on. And so this whole thing justifies that your architecture, your model should have its own repo distinct from the train or API one. Second, from a very MLOps point of view, the model is traveling between different teams, as we said, different repos. You first train it, then you have your API, then you put it into production. So you need, for the architecture itself of your deep learning model, you need to have a single source of truth for easy deployment and versioning. And so PyPy, which is the package manager of Python, really plays this remote role of being the SSOT in a sense for your model architecture. And so I will just let Cedric now explain why we developed that.
Sure. I'm sorry, I think I was disconnected earlier. This brings us to our solution, the torchTextClassifiers package. We developed this package as a toolkit to embed the different components of a text classification model. It should distribute state-of-the-art architecture, including self-attention layers. The key principle behind the package is flexibility. The idea is to easily instantiate and train all components with additional features like explainability. You can also use any tokenizer from Hugging Face or train your own. This package is targeted essentially all those who want to train their own made, maybe small, models for text classification and want to customize their architectures for their needs.
So,
We also want to keep it fully open source. I'll just add that because we believe in fostering a community across this package.
Absolutely. And so just to summarize a bit, who is the target for this kind of package? Basically, if you have a lot of data and you have a lot of compute, you can split basically let's say, your use cases with two, let's say, axes. The first one is how much labeled data sets size do you have? And first, the computing power. For the computing power, either you have no GPU at all, or you can have a GPU for training, like you have some cluster to train your models, but you cannot put a GPU into production, because when you put a GPU into production, you like fully freeze this GPU for your use case. Or you have a lot of compute and you can allow yourself to have a GPU that is completely mobilized for production. So this is the other three, like, let's say, splits that can be done. And in terms of data set size, either you don't have like very few label data, or you have just enough to, like, let's say, fine tune something, but not enough to train from scratch, or you have enough data to train from scratch. So of course, if you have no data and a lot of computing power, so like you can put a GPU into production, you will go towards more LLM inference or zero-shot models and so on. So this is not our target. If you don't have enough data to train a model from scratch, but you have enough data to, let's say, fine-tune zone, you will be in the fine-tuning zone here. But to be in the fine-tuning zone, you need to be able to have a GPU for production, because on Hugging Face, you cannot have the control on the number of parameters of your model and the size of the model. So you will have to be able to handle big models from Hugging Face and then fine tune them. And if you want to put them into production, you are very likely to be to need a GPU for production. If you don't have a lot of compute and no data, unfortunately, will be here, where you cannot like fine tune a model or even not put into production. So we'll be in the blank zone here. But if you have enough data to train a model from scratch, and if you are typically in a case where you have a GPU for training but not for production, which is which is the case for a lot of organizations out there, you will be likely, like, you are the target of the package. You have a lot of data and not enough GPU to put one into production, but you have one GPU for, like, let's say, training a model. And so you want to do your own architecture, you want to customize your model, reduce the number of the parameters, for instance, and then train your own model. And so without further ado, we'll try to do a demo of the package, how it's built. And so before doing that, I will just go with you to deep dive into the different components of how we conceptualized the notion of a text classification model. So first, a text classification model it takes a raw text. Then you have a tokenizer that can come from Hugging Face, for instance, but it's optional. You can do also an n-gram tokenizer, which is completely in Python and so on, and we propose one of them. So this outputs a tensor in PyTorch, and it goes through your text classification model, which is a PyTorch thing. You have a text embedder, a classification head, and then you have your labels here, and you do whatever you want with your labels. Also, you have a categorical variable net, which is another PyTorch module that will help you handle the different categorical variables that you have additionally to the text. And so basically what we propose is to orchestrate all of this, is to first propose these components, then to orchestrate them and easily train them. And finally, we propose a wrapper. As we said, this notion of wrapping is quite central in our work, to go from raw text to labels. And so this is very thought as something which is part of an MLOps pipeline where you want to deploy something. And so let's go to the demo. We don't have much time left, so I just put the link in the chat, and then we'll just go quite quickly into that. And if you want to go deeper into this demo, you can freely take your time. So let's say we have here our data. So sorry, it's in French once again, but it's not relevant here. You have some text, some variables here, categorical, and you have your labels here, which is the column appet final here, which is the base code. So basically, I just have to clean it to put everything in int format. You do your classic train split. And so if you are advanced PyTorch user, you can manipulate your components yourself. So you can manipulate your tokenizer. We propose an object which is called Hugging Face Tokenizer, and you can load a pre-trained one, or you can train your own one. So this is available in the package, the tokenizer object. We propose also a dataset, PyTorch dataset for easy training and so on. You can see here. So it pads for those who are accustomed to the notion of padding and so on, in tokenize and pads everything for you. And then you have your PyTorch model with subcomponents that are text embedder. The text embedder, you can add self-attention layers if you want. You can just customize the number of self-attention layers that you want. So it's quite nice if you want to have some more relevant embeddings without making explode the number of parameters. And then you have your text embedder that outputs a given tensor in PyTorch. You have a category variable net here, classification head that goes back into the label space of in our case, it's 732 labels. So that is quite simple, quite easy to manipulate. And you have also a module here, a lightning module for easily training. We're using a PyTorch Lightning. Okay, and this is the wrapper. The wrapper, the idea is that it orchestrates everything for you in a few lines of code. You just have to specify some hyperparameters. And so basically here, in a sense, you can forget everything that is above. And let's say you are not a big PyTorch user, just want to really quickly train something. So it's doable in a few lines of code. You can instantiate a torchTextClassifier object, a wrapper, using only some critical hyperparameters here. And then you have everything that is done for you. The tokenizer is done for you. The model is done for you with the different subcomponents here you can see. And you can easily train using just .train data. So that's the idea. The idea is really to orchestrate, manipulate, and wrap everything without forgetting what's inside. That's the main idea of this package. And so you can do then prediction. And just to show you a bit the explainability pipeline that we have implemented. For instance, here we're using integrated gradients from Captum. And so it shows you which token has driven the prediction. So that you can do this kind of graphs and so on to understand if your model has understood and where its focus is when it tries to predict something. So yeah, that's it for the demo. I will get back to the presentation. And so once again, I've put the link in the chat, so feel free to we also have the documentation, quite extensive here. I will put into the chat if you want. Here we are. So yeah, I've seen your question, Ryan. I will get back to it just after the presentation. No worries. And so yeah, to end up with the perspectives. So yeah, in terms of MLOps, we really want to keep bridging the gap between innovation and production. As we said, some of the steps are not automated yet. If you remember the plot at the beginning. So really want to achieve a full automation and the eternal knot of MLOps, the ideal pipeline in a sense. And this observability of the model, for instance, is highly critical. And for the package itself, we want to keep going and include even more SOTA architectures, such as gated attention, text label cross attention, and so on. We want to put some methods on controlling uncertainty in deep learning models, quantization, push-pull connection with the Hugging Face universe, and so on. And of course, as Cedric pointed out, it's always fully open sourced. We are a government organization, and so it's part of our core focus to open source everything that we do. And this package is open source, available on GitHub. And so feel free to raise an issue or submit a PR if you want a new feature. Thank you very much for your attention, and you can find all of these project repositories, including train, API, deployment, and so on this QR code. Thank you very much. And so I just answer to this question, how much data is enough data? So of course, this is the question that comes back every time. um, it depends. It really depends on the number of labels that you have. It depends on your use case. Basically, if your text is clean, if the link between text and labels is easy to learn or not. So it really depends on the statistical distribution of your text and your labels, in a sense, the joint statistical distribution. Yet we can say that you will need 10 to the power 4 range, something like that, like 10K text to be able to train something. But this is not a global truth. It can really depend on your use case.
Thank you very much for this section. So please, we can continue the engagement on the chat. I don't know if Marina still have any other information. I know you have got some of the insights in the chats that you can also use into and also ask questions on the Discord. Thank everyone for joining and thanks for the amazing presentation too.
Thank you very much.
Thank you.
Okay, so please, we'll get set for the next section in a moment. Thank everyone for joining. Please let's reach out on the Discord for further discussion. Bye everyone.